So this is your warm-up for quiz number 2 in Unit 1. And hopefully you attempted the warm-up first before watching this video. If you have not tried to do the warm-up by yourself, you should do that before you watch this video. That being said, I'm going to jump right in to number 1, which asks, which of water, iron, ammonia, chromium, radon, and silicon are chemical compounds and not elements? Well, we know that if it's an element, it will be on the periodic table. So if we go looking, iron is on the periodic table, it's Fe. Chromium is on the periodic table, it's Cr. Radon is on the periodic table, it is Rn. And silicon is on the periodic table, it's Si. Water is not an element on the periodic table. In fact, you probably already know that water is H2O. That has two elements right there, hydrogen and oxygen. If that's two elements combined, that's going to be a compound. Ammonia is also not on the periodic table. Just for the record, it is NH3. That's also two elements, capital N, capital H. So that's nitrogen and that's hydrogen. I don't expect you to know that ammonia is an H3, but since you can't find it on the periodic table, you should know it must therefore be a compound, because it's not on the periodic table. So if water is a compound and ammonia is a compound, then we should be looking for answer choice D. Number 2, an example of a heterogeneous mixture is, and then we got some options here. Gold is on the periodic table, it's an element, so that's not a heterogeneous mixture. Water, we know water is H2O, that's two elements together, that's a compound, so that's not a heterogeneous mixture. That leaves us with brass and concrete. There's two ways you could think about this. First of all, hopefully you know that brass is an alloy, and that all alloys are homogeneous mixtures. The other way you could think about it is with concrete. If you look really closely at concrete, some of it just looks like pale gray, but some of it's got like little shiny, sparkly things. And if there's shiny, sparkly things in it, and other areas where there's not shiny, sparkly things, that is not well mixed. If it looks different to your naked eye, that is not well mixed. And so that's going to be a heterogeneous mixture. Number 3, an unknown pure solid was heated. No signs of chemical reaction occurred. After heating, the solid looked the same as it did before heating. What type of substance was the solid? Well, this word pure is a big clue. Mixtures are not pure, by definition. Mixtures, by definition, are not pure. To be a pure substance, it cannot be a mixture. It has to be an element or a compound. Both of these are what we call pure substances. Now, if you heat one of these versus the other of these, and no reaction occurs, then that could tell you a couple of things. For this to be a compound, there are some compounds that you could heat small amounts or whatever and it wouldn't react. But there are other compounds that you could heat and that they would react. So we don't know for sure whether or not it's a compound. But if it heats and does nothing, it definitely could be an element, because just heating up a pure element is not enough to make it react. It would have to interact with something else. So the safest answer here is element. Let's look at number 4. How is a mixture different from a compound? It says particles of a mixture are combined chemically. That's not true. Particles of a mixture are combined physically. So A cannot be the answer. Components of a mixture can only be separated chemically. Again, that's not true. Components of a mixture have to be separated physically, like filtering. or even just pulling pieces out of the mixture individually. Components of a mixture can be separated by physical meanings. That is true. Let's double check answer choice D. Composition of a mixture may be constant. That's true, but that's not different from a compound. That is the same as a compound, and that's only true for homogeneous mixtures. So that's not different from a compound, so that's not going to be our answer choice. But a compound cannot be separated by physical means. A compound must be separated by chemical means. So C must be our correct answer. Looking at number 5, which words best describe a pure sample of glucose? Well, C6H12O6 is glucose. There's 3 capital letters here, so that's 3 elements, which means this cannot be just one element. However, when they are written combined out like that, that should tell us when we look at it, oh, that's a compound. 3 capital letters all together like that, that's a compound. We also know that a compound is a pure substance. We even mentioned that earlier. The elements and compounds are pure substances. And if it is a compound, it cannot be a heterogeneous mixture. You cannot have something that is both a compound and a mixture. It has to be one or the other. So that means we're looking at Roman numerals 1 and 4, and that's supposed to be D right here. I guess we need to fix the formatting on that. Okay, next. Zoom out a little bit. We're marking if these properties are physical or chemical, and if they're intensive or extensive. Remember, for a property, this is something that you can observe without changing the identity. If it's physical, or if it's chemical, it will change the identity of the thing when you observe it. Intensive is independent. Intensive is independent of amount. No matter what amount you have, it's always going to be the same value number. And extensive depends on how much you have. Depends on how much there is. So if we're reading that the mass of a cup of water is 50 grams, first of all, if I measure the cup of water and I measure that it's 50 grams, the act of measuring does not change what it's made out of, so that's a physical property. But the 50 grams does depend on how much stuff there is. If there was more stuff, it would be 100 grams or 150 grams or something. If there was less stuff, it would be maybe only 25. So since it depends on how much there is, that makes mass 50 grams an extensive property. The second one, chemistry booklets are orange. If I look at something and see what color it is, I have not changed the thing just by checking its color. So that's another physical property. Now, the booklet would be orange whether you had your whole booklet or whether part of your cover had been ripped off. That paper would still be orange. So no matter how much you have, if you have the entire booklet or if you only have part of it because it ripped, no matter how much you have, it's still going to be orange. It's independent of the amount, which makes it an intensive property. Arsenic is very toxic. The only way you can observe if something is toxic is to let it, poison you or poison something. And in that poisoning, you're going to get sick because it's changing your cells. So toxic is a chemical property. It has to change cells in order to show that it's toxic. It breaks apart like molecules in your cells. Now, whether or not it's toxic doesn't depend how much arsenic you have. Even a drop of arsenic is still toxic. You wouldn't get as sick from just one drop, but you would still get sick because it would still be toxic. So, since it doesn't matter how much there is, it's toxic whether you have just one drop or whether you have a whole glass. That is independent of how much you have, and that's an intensive property. Gold is very malleable. Remember, malleable means that it bends easily. Observing that gold will bend easily does not actually turn the gold into anything else. It's still gold, it's just shaped different. So that's a physical property. And gold's going to be malleable whether you have one tiny little bead or whether you have a whole bar. It's still going to be malleable, independent of how much you have. So that is intensive. Uranium is very radioactive. The only way you're going to observe if something's radioactive is, again, radioactivity will change cells. There will be, if you're observing something as radioactive, it is already changing cells by hitting them with radiation. So if you have some changing going on, this is a chemical property. But uranium is going to be radioactive whether you have a little tiny nugget of it or whether you have a whole, like, enriched bar or whatever. So since it's independent of how much uranium you have, that is another intensive property. Then there's some matching. Match the following substances with the type of matter, and you are allowed to use this stuff in the word bank more than once. Tin, and then it's got a symbol, SN. Hey, that's an element symbol, and if you double check, tin is an element on the periodic table, so yeah, I'm going to call this an element. Calcium nitrate is what this thing is called. It's CaNO3. So I have 3 capital letters. That means 3 elements altogether. When it's written like this, that's a compound. Okay, ice. I always get people telling me this is like some kind of mixture, but if you think about it, ice is water, right? And water is H2O. So guess what? That's another compound. Now, coffee is a mixture of water plus some dissolved stuff from the ground up coffee beans. So that's going to be some kind of mixture. If you are drinking a glass of coffee, it should be a homogeneous mixture. It's supposed to be a homogeneous mixture, right? You're not supposed to have a bunch of crap floating in your coffee. And it doesn't say like iced coffee, it just says coffee. So we're going to assume that's a homogeneous mixture. Usually your coffee, if it's made correctly, is well mixed. You know, there's not a bunch of like coffee grounds floating around it if it's been made correctly. Pizza, well, if you think about a pizza, you got like your crust, okay, and on top of the crust you have some sauce. And on top of the sauce you have some like cheese and maybe like some meat or vegetables or whatever. That's a whole bunch of stuff together, and it's not well mixed. The crust is a different area. It's like the whole bottom is crust and the sauce on top and the cheese on top. Those are not well mixed together. That's a heterogeneous mixture. Our very final question asks, what is the density of a substance that weighs 105 grams and has a volume of 83 milliliters? And you have to show your work. On your quiz, you also have to show your work. If you just write an answer down and nothing else, you're not going to get credit for it, because I don't know if you found that answer, if you took it off of somebody else's paper. So show your work. Remember that density is mass divided by volume. They tell us it weighs 105 grams, so that's going to be our mass. It has a volume of 83 milliliters, that's our volume. So we're just going to plug in our stuff, 105 grams over 83 milliliters, and then we put it in our calculator. 105 divided by 83. And you get 1.265060, blah, 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 blah. We don't need all of those. We're just going to round to the hundredths place. But remember that looking next to it, this 5 is going to make it round up. So instead of 1.26, we're going to write 1.27. And our units for density are grams per, and then whatever the volume used. The volume was milliliters this time, so we're going to say grams per milliliters for our units here.